In this lesson, we're going to look at applying the sine law. The primary trig ratios, sine, cosine, and tangent, can only be used when solving right triangles. Now, right triangles mean that we have one 90-degree angle in our triangle. But the sine law can be used to determine unknown side lengths or angle measures in acute triangles. That means all three of our angles are less than 90 degrees. You can use the sine law to solve a problem modeled by an acute triangle when you know two sides in an angle opposite a known side, two angles in any side, or if you know the measures of two angles in a triangle, you can determine the third angle because the angle must add to 180 degrees. When determining the side lengths, it is more convenient to use this form. You put a box around that. That's something you're going to want to put on your study guide. So the side lengths are on top. We use lowercase letters for side lengths and capital letters for angle measures. And then when we're determining the angles, you flip the whole formula upside down. So we use the angles on top and the side lengths at the bottom. Just remember when you're using the angles, it's sine of the angle, not just the angle. So ensure that you put those together. Alright, it's okay for me to tell you these when to use rules, but until you actually see some questions and start working out some problems, this doesn't really make too much sense. So let's go and see what the sine law is all about. Take a look at the first example here. It says, show that the sine law is true for the following triangle. So there's lots of stuff going on in this triangle. We have angle measures, we have side measures. So basically we want to see what is actually going on in this question. Our triangle is already labeled in terms of its angle measurements, so angle A, angle B, angle C. When we're labeling our side lengths, the lowercase letter is used for the side lengths, and it's always opposite the capital letter. So directly across from capital A is lowercase a, directly across from capital B is lowercase b, and directly across from capital C is lowercase c. So that's how we label those side measures. Whoops. So if we rewrite our formula, A over sine of angle A is equal to B over sine of angle B, and C over sine of angle C, we can substitute all of the information and see if this formula is actually holding true. Side A is 39.7. And then angle A is 50.4, but it's sine of 50.4 degrees. And so on. So continue to fill that out. Once you have all your values substituted, you can use your calculator to solve each ratio and see what they're equal to. So let's take a look at the first one here. I'm just going to make this smaller so I can see my values. Where is it? Okay, so the first one is 39.7 divided by sine of 50.4. 39.7 divided by, oh, and before I do that, just double check. Yeah, okay, I'm in degree mode because you want to just make sure that you're there. So divided by sine, what did we say that was? 50.4. We get 51.52. Alright, so go ahead and do that for the other two ratios. Now I'm putting an equal sign here, but it's really a question mark. Is it equal to the other one? So go ahead and try those ones out as well. So when I did this, I got 51.52, 51.42, and 51.55. So I would say, in general, those are very close to each other. Ideally, those would all be identical in order for that to really hold true. But you can see how the sine law works. Now, if we flip the whole thing over and use the other form, sine A over A, sine B over B, and sine C over C, we would get a different answer, but they would all still be the same. Okay, so the formula works both upside down and right side up, just depending on what you're using. And we usually don't use all three. We choose two, whatever two are going to best suit our needs for what we're solving for in the question. Alright, let's take a look at an application question here. Example 1. Using reasoning to determine the length of a side. A triangle has angles measuring 80 degrees and 55 degrees. The side opposite the 80-degree angle is 12 meters in length. Determine the length of the side opposite the 55-degree angle to the nearest tenth of a meter. Whenever I get questions like this, I always have to draw it. Now, how you draw it, it doesn't have to be completely to scale, but just to give you an idea of what it's supposed to look like. So if I draw this here, I have my 55-degree angle here, my 80-degree angle up here, and then it says the side opposite the 80-degree angle is 12 meters. Determine the length of the side opposite the 55-degree angle. So this is my unknown. And we want to round to the nearest tenth of a meter. So we're solving for a side length, so I'm going to rewrite the formula in this way, our sine law, and then determine what information from the sine law I need to use. So always start that way. Decide, am I finding a side, am I finding an angle, so you know which version of the formula you want to use, and then decide what we need to do from there. Now, I'm going to label my triangle. I've got A, B, C. If you labeled it differently, that's fine as long as you're consistent. So I need to use my lowercase letters. This is A, this is C, and this is B. Now, looking at this, I can see angle A and side A I need to use for sure because that's a pair. I've got information for all of this, A and side A. I want to solve for side B, and I have angle B. So that's the other pair I'm going to use. C and angle C, that's not really useful to me because there's no information given. I could solve for this angle C, but it's still not going to be useful for me because I don't know what side C is, and I'm not trying to solve for it, so it really doesn't matter to me at this point. So let's rewrite the formula just with A over sine A and B over sine B. So we've got a new ratio that we're working with. Substitute the information. So A is 12 sine 80 degrees, and then B is what I'm solving for, and then sine B would be sine of 55 degrees. Now, one of the big mistakes that students make is they round too soon. So my suggestion is keep as many decimal places as you can, if not all of them in your calculator. Try to rearrange and solve, and then just put everything in at one step so you have the most accurate answer possible. So at this point I can see that I'm solving for x, so I need to get rid of that sine 55. You can think of cross multiply and divide, or you can say, well, I'm dividing by sine 55, so if I multiply both sides by sine 55, that would cancel there, and then I would have this side sine 55. Okay, now I can put that on my calculator in one shot. I've got x is equal to 12 times sine of 55 degrees all over sine of 80 degrees. Let's see how we can put this in our calculator in one step. So I'm going to clear out what I have. So I've got 12 times sine of 55 divided by sine of 80 degrees. Putting all of that in, you get an answer of 9.98146. And so on. The question specifically says, answer to the nearest tenth of a meter. So that's one decimal place. Well, one decimal place in this case would be 10.0. So what are we solving for? The length of the side opposite 55 degrees, and we've got it in meters, so we should say that the length is 10 meters. And that's our final answer for example 1. Let's have a look at example 2. Solving a problem using the sine law. Toby uses chains attached to hooks on the ceiling and a winch to lift the engine at his father's garage. The chains, the winch, and the ceiling are arranged as shown. Toby solved the triangle using the sine law to determine the angle that each chain makes with the ceiling to the nearest degree. He claims that theta is 40 degrees and alpha is 54 degrees. Is he correct? Explain and make the necessary corrections. So in order to solve this, we're going to actually do this 2 times. We're going to use the sine law 2 times. Once to solve for theta and once to solve for alpha. Because I'm solving for the angle, I'm going to use the flipped over version of the sine law. So that's angle A on top. So sine of angle A over side A is equal to sine of angle B over side B, and sine of angle C over side C. Let's start by solving for theta. Well, theta, if we label this A, B, C, that theta would be our angle A, so side A would be 2.2. So that's a pair. That's the sine A over A pair. And then I've got B over side B. Well, that's a pair. But then I also have C over side C. So I've got all 3 pairs. So what exactly am I doing here? Well, if I'm solving for side A, that's an unknown. Or sorry, angle A, that's an unknown. Angle B is also an unknown. So those paired up isn't going to be good for me because I'm going to have 2 unknowns. So if I have sine A over A and sine C over C paired up, that's going to be useful because C, both of those are given, and for A I have 1 unknown. And then I'll pair up C with B and solve that one separately. So, sine A over A is equal to sine C over C. So I've got sine of theta, if I plug in the information from my question, over 2.2. And I've got sine of 86 over 2.8. When you're solving for the angle, it's a 2-step. We're not just getting rid of, like in our other question here, where was it? In this question, we just had to get rid of the sine 55 on the bottom and then multiply and divide, and we were done. Whereas when you're solving for an angle, yeah, we have to get rid of the 2.2 that's attached to the theta. So let's start there. So I can multiply both sides by 2.2. But then that's not going to be enough. The reason for that, you can see once we simplify, I'm still left with the theta attached in with the sine. So I've got 2.2 times sine of 86 degrees, all divided by 2.8. So that's nice, and we can solve for that. But how do we get rid of the theta? The sine attached to the theta. We just want theta. Well, in order to solve for an angle, if you remember back to trig, we do inverse sine. So the same way if you have something squared, we square root it to undo it. The same way the opposite operation of multiplies divide. The operation that undoes the sine of something is to inverse sine it. So if we take theta would be equal to sine minus 1 of all of this stuff. So 2.2 times sine of 86 degrees, all divided by 2.8. And if you put that all in your calculator, you'll get the angle out. So let's practice that together. So I go inverse sine, or second sine. Now in there, we had 2.2 times sine of 86. You can close that. And then divided by 2.8, and then you can close that one. And you should get 51.6 degrees. And you can see by putting all of that in there, you're going to get the most accurate answer because you're not rounding as you go. At this point, we can compare back, and we could see that Toby measured theta to be 40 degrees, and we've just measured it as 51.6 degrees. Now, it also says that he measured to the nearest degree. So we can say, or 52 degrees, right? So 52 degrees is what we got as theta. Now, we can go ahead and do this all over again using sine B and sine C and solving for that. But if we look at our question here, instead of 51.6, I'm going to put 52 here. If we look at our diagram, well, if I know 2 of the 3 angles in a triangle, then we can just use our sum angle formula to find that third angle. So alpha is equal to 180 degrees minus 86 degrees minus 52 degrees. So alpha would be 42 degrees. We can just write a statement at the end explaining what we did, and our math is also going to support our answer there. Let's take a look at another example. Example 3 says using reasoning to determine missing information. So triangle SUN has n equal to 58 centimeters, angle n equal 38, and angle U equal to 72 degrees. So again, this is going to be a question where we're going to want to draw the diagram. So I've labeled angle n 38 degrees, angle U 72 degrees, and we're also given that side n, which would be directly across from angle n, is 58 centimeters. And this is triangle SUN, so this would be S. Now it says draw a label diagram. We've done that. Determine the length of the side U. So this would be side U to the nearest centimeter. So we normally have A over sine A, B over sine B, C over sine C, but that's really not going to help us here when our letters are S, U, and N. But you can set it up the exact same way. So you have S over sine S, U over sine U, and N over sine N. And I used again the lowercase letters on top because I'm solving for a side. So I know when I'm solving for a side, the side that I'm solving for, that pair must be used. And then whatever other pair of information I have. Well, S doesn't give me anything, so I'm going to use N in this case. So U over sine U and N over sine N. Substitute the information. By now you've done an example like this, so I'm going to leave this up to you to finish and then come back and check with my answer. Once you solve this, you get 89.6 in your calculator, but it says to the nearest centimeter, so that would round up to 90 centimeters for that question. That's it for today's lesson. You can see there is one more example on the next page, but we're going to leave that one out for now. So thanks for joining me.